Hi, my name is Philip. I'm going to talk for the next 10 minutes or so. Then David will give a brief live demo of the online Python tutor system and then try to connect me on Google Plus Hangouts so I can answer your questions remotely. But in case the internet connection doesn't work out, that's okay, because Andrew and David, who are the lead authors on the other two papers in this session, are both very familiar with my system because they've actually used it as part of the systems they'll be presenting. So I'm sure they'll be able to answer your questions as well. The fundamental problem that beginners face when learning to program is the following, is how to map between source code, or the text written on the screen, and execution, or the dynamic process by which an abstract machine is executing their programs. Currently, instructors teach this concept in a fairly low-tech way. So what instructors would often do is draw diagrams on a blackboard and simulate the computer's execution. The instructor here is simulating a method call of pushing parameters on a stack, adjusting values, erasing pointers, and then redrawing other pointers. Clearly, this is a very tedious and error-prone procedure for the instructor, right? Because they have to do all this drawing on the blackboard and erasing, or alternatively, they have to spend a lot of time making PowerPoint slides with all of their diagrams and arrows and everything. But in my view, the more limiting thing here is for the student. So students can't easily explore what-if scenarios. So we know that students learn best when they can actively grapple with the material and say, what if I change this to that? Or what if I change this pointer to that pointer? What happens to my execution? But when they're watching a lecture on a blackboard or a PowerPoint slide or on YouTube, they cannot easily ask these sorts of exploratory what-if questions. To address these limitations, I've been working on a tool called the Online Python Tutor for the past few years. And this is a website you can visit at pythontutor.com. It's a pretty simple interface. You type or paste in Python code in the browser, set some options, such as the Python version and some other display options, and then hit Visualize Execution. Now this brings you to the following screen, where the upper left shows the code that you're going to visualize, and the red arrow points to the next line to be executed. So this is just like a symbolic debugger. When I hit forward, it will execute the first line. And in Python, this line means to create a new list object and then point a global variable x to it. So the upper right shows the visualization, just like an instructor would have drawn on the blackboard or a PowerPoint slide. When I hit forward again, line 2 executes y equals 4, 5, 6. It creates a new list. Now the red arrow is over the third line, z equals y. This is something that gets beginners very confused oftentimes, and rightly so, because in different languages, in say MATLAB or Python or Java or C or Python, it might mean different things. So here, when I execute in the visualizer, it becomes very clear what this line means. It means that z and y are both pointing to the same list object. There's also a slider on top where you can go actually back and forth between execution points, so actually you can see what happens as you execute your program forward and backwards. You can hit the edit code link, which will let you edit the code live and then re-execute. And this is how you can test out these what-if scenarios. What if I change this pointer to that pointer, and so on. Because it's on the web, it has some cool features like you can generate a URL. You can actually snapshot the current state of your visualization, put it in a URL, and then send it to your instructor or post it on a discussion forum and then talk about the visualization. You can also generate code to embed the current visualization in any other web page because it's simply a standard set of HTML elements. I want to briefly talk about implementation now. The backend runs on a web server, and it uses Python to generate an execution trace using the PDB debugger module. So PDB is a Python debugger that lets you single step through execution, stopping after every step, and then I have custom Python code that introspects all the frames and stack and heap and just everything that's in scope. And then I encode the trace in a special JSON format, which contains all the information that's in scope at every particular program point that's being executed, and then I send that trace to the front end via a web call. The front end runs in the user's web browser, and it's simply a lot of JavaScript code to take the trace and to visualize it in the browser. So it uses a standard library called jQuery to do a lot of the DOM manipulation, a library called D3 that allows you to do really nice mapping between the data in your JSON trace and specific visual elements. And then a library called JSPlum that allows you to draw these nice curves and arrows for representing pointers. I've just been really excited by the impact that this tool has had over the past 3 years since I started working on it. So over 200,000 people have visited the website so far and been playing with the visualizations to learn programming. It's being used in a dozen traditional university CS courses. In Coursera's large Intro CS course with 34,000 students, the lecturers have used it to create their lecture materials and also as part of their exercises. It's being used by students taking online courses from Udacity and edX, the two other big providers of these massive open online courses. And they've discovered the tool and been playing with it and been discussing it in the forums. And finally, it's being used in 3 digital textbook projects, one of which David will be presenting later in this session. And these digital textbooks reach over 200,000 people per year. And that's in addition to the 200,000 people that have visited the official online Python Tutor website. I want to now show you some screenshots from use cases. This is the intro class at UC Berkeley. This is the fall 2012 offering. It has around 700 students. This is one of the biggest in-person lecture classes for Intro CS that I know of. And here is an instructor generating a lot of online Python Tutor diagrams and pointing to them during lecture. So he used this throughout the term to illustrate all sorts of concepts in the class. The TAs also use it a lot when tutoring students one-on-one. So here is a use case on an iPad. Because it's simply a web app, you can visit it on any device, such as a tablet. And you can actually share it around and play and feel the visualizations and pass around the iPad to different students. So that's really cool. They took a post-course survey asking a few questions, such as, how do you feel about environment diagrams? And the feelings of the concept of these diagrams are sort of mixed. Some students really like them, some students didn't like them. But a follow-up question is, how helpful did you find this online tool for drawing the environment diagrams? This online Python tutor tool they used during class, and overwhelmingly people found online Python tutor really helpful in understanding the course material. So I was pretty happy about these results. This is a use case in a digital textbook. So this is How to Think Like a Computer Scientist, interactive edition. The author has taken the text of this textbook and then augmented it with my code visualizations from online Python tutor. So students can read the text and then edit the code and then play with the visualizations all on the same page. Here's a use case on forums for MOOCs for these massive open online courses. This is the intro class from edX. And here a student has posted a question and created some visualizations with Python Tutor where the red arrows are pointing to, and then ask questions about it. So if you actually click on any of the links, it'll bring you to the Python Tutor website with the visualization that the student was confused about, and then the student can ask questions and discuss in that context. And now David will spend a few minutes demoing the system live, and then try to get me connected on Google Plus Hangouts. And again, if in case the connection doesn't work, I'm sure that David and Andrew will be able to answer a lot of your questions.